When you see a factorial in a series, it's usually a good indication that the ratio test will be helpful for determining whether it converges or diverges. So let's apply the ratio test to this series. My terms are all positive, so I don't need to worry about the absolute values. For my numerator, k becomes k plus 1. For my denominator, it doesn't change. As usual, if I want to simplify this, it's usually nice to collect things that came from the same place. So this numerator gave me this numerator here and that numerator down there. So let's put those together. 10 to the k plus 1 divided by 10 to the k. Then this denominator gave me this denominator and that denominator. So again, let's put those together. Ten to the k plus 1 divided by 10 to the k is just 10. And for the factorial bit, remember I can write k plus 1 factorial as k plus 1 times k factorial. That's k plus 1 times k times everything less than k. So now I have the limit as k goes to infinity of 10 over k plus 1, and that's 0. 0, crucially, is less than 1. Using the ratio test, our r was less than 1, so the series converges. Now it's your turn. Pause the video, use the ratio test to determine whether this series converges or diverges. That factorial is a good hint that the ratio test will probably be helpful. In the numerator, all my k's turn into k plus 1s. In my denominator, they all stay the same. Because these terms are positive, we don't have to worry about the absolute value. As usual, let's group terms that came from the same place. These are our two numerators, our two k to the k's. And our denominators are the factorial parts. Let's give ourselves a little bit more room here. For the term on the left, if I factor out one of the k plus 1s, I'll have the same exponent on the top and the bottom. So I'm going to rewrite this numerator as k plus 1 times k plus 1 to the power k, and the numerator stays the same. On the right, I'm going to write k plus 1 factorial as k plus 1 times all the numbers less than k plus 1. On the right, I have this nice cancellation. On the left, I'm going to factor out the k plus 1, and now I can write k plus 1 over k inside the parentheses and leave the power k outside of it. And I get another nice cancellation. So I just need to find the limit as k goes to infinity of 1 plus 1 over k to the power k. Now this is actually one way to define Euler's constant, E. Now it's tempting to say the inside goes to 1 and 1 to any power is 1. The problem with that is the inside is a little bit bigger than 1. And when I take something bigger than 1 and I start raising it to a really big power, that thing starts getting big. This is a limit that's nice to have memorized. E is about 2.7. In particular, it is bigger than 1. Altogether, because we saw a factorial, we wanted to use the ratio test. We calculated our limit r, that was greater than 1. That tells us that this series diverges. I want to give a little aside here. In this case, if we were clever enough, we actually could have used the divergence test. The terms being added up are k to the k over k factorial. In the denominator, there are k terms multiplied by each other. K, 1 less than k, 2 less than k, all the way down to 1. In the numerator, there are also k terms. They're all k. So if I were to pair these up, this is 1, This is a number greater than 1. 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 So no matter what k is, as long as k is at least 2, all of the terms are bigger than 1. That means my limit is not going to 0. The terms I'm adding up are not getting smaller and smaller going to 0, so by the divergence test, our series diverges. Why don't you take a minute, have a try at this one. We see the factorial, so it occurs to us that we ought to use the ratio test. So we compute our r. Because the terms are positive, we don't need absolute values. K becomes k plus 1. K becomes k plus 1. K becomes k plus 1. And in the denominator, it's just k's. As usual, for evaluating this limit, it's really nice to group similar terms together. So these two both came from this part of the numerator, so I'll put those together. This k factorial gave me a k plus 1 factorial and a k factorial. I'll put those together. And finally, 2 to the k gave me these two terms in pink. For the first term, I can factor out a k plus 1 just like I did before, and now both the numerator and the denominator are being raised to the power k. For the second bit, my denominator can be written as k plus 1 times all the numbers less than k plus 1, that's k factorial. And for this third bit, I can divide the top and the bottom by 2 to the k, and I'm left with 1/2. K factorial and k factorial cancel. K plus 1 and k plus 1 cancel. So I have 1/2 times 1 plus 1 over k to the k. And what I saw before is that this is one way to define e. So now my ratio is e over 2. E is about 2.7. So this is still bigger than 1. So it's still true that, using the ratio test, we find r to be bigger than 1, so the series diverges.